Hello everyone, this is the lecture for section 4.2, Graphs of Exponential Functions. So in this section, we're going to cover exactly what the title says, Graphs of Exponential Functions. Turns out, much of the stuff that we all learned in chapter 1 is still completely applicable here, okay? I will add one caveat, right? If you recall when we were going through chapter 1, right? And we were going through transformations in particular, right? I said that I was going to defer certain portions of graphing toward a later chapter, right? This is that chapter. This is where I'm going to introduce sort of the full length of everything the full thing, everything for graphing any function, okay? So let me start with just one observation, right, when graphing exponential functions. There's two graphs here, right? One of them, I'm going to write the equation here, right? If you recall what an exponential function looks like, right? It's like that. Oh, x, b to the x. Okay? So we have these kind of functions here. In particular, there are two of them. There's this one, the g of x is equal to 1/2 x, which is on the right hand side of the screen, and then we have f of x, which is 2 to the x, which is on the left hand side of the screen. Okay, and what I want people to notice is this. If you have this one, right, notice how the graph goes. It starts from sort of down low and heads up high. It goes that way. Okay, that's what happens when you have 2 to the x. Right? Okay. If you have this one, the g of x, which is 1/2 to the x, right? It starts up high and then sort of trickles down that way, like that. Okay? That's what happens when you have 1/2. Okay? Now, hopefully you guys see where this is going, right? The idea here is if your b is bigger than 1, right, then your graph is going to do something like this. It's going to do this kind of thing. It goes whoosh like that, right? And then opposite, right, if your b is between 0 and 1, right, you're going to have something that does this. It goes the other direction. It's going to drop like this, whoosh, up. Something like this, whoosh, down that way, bam. Okay? Okay, now, what I want everybody to do is, if you need to, okay, pause the video and take a look at the points. Some nice stuff is going to happen right now in a second when we look at the points, okay? Hopefully you guys are making some sort of connection between the points between the two on the left and on the right, okay? All right, keep those points in mind for now, okay? All right. Let's go ahead and go back to graphing using transformations, okay? So the first thing I'm going to do for this example, okay, is there are 3 graphs that I'm going to graph. That one, and that one, okay? So the base one is 2 to the x, okay? So if you recall, it's going to look something like this. That's going to be the first point. This is going to be the second. This is going to be the third. And this is going to be the next one. Okay. Actually, I should color them in blue instead. There we go. Okay. These are the points for the regular old vanilla 2 to the x without any transformations at all. Got it? All right. So now, this is where you guys will see what the fact that we've already learned all this, right? So let's start with this one. Let's start with this one right here. Hopefully you guys remember what that +3 does, right? If it's away from the x, that is a vertical shift, right? Up and down. So that's what this is. I'm gonna grab every point. So that one's gonna be 1, 2, 3. This one's gonna be 1, 2, 3. Same way that we did it before. 1, 2, 3. 1, 2, something up there, right? This one's gonna be 1, 2, 3. This one's gonna be 1, 2, 3. Keep a track of everything, right? 1, 2, 3. Okay, and hopefully you guys see, now we can play connect the dots. Starts down here. I'm trying to make them go through all the points. There we go. Yeah, close enough, right? Okay, so then that is g of x. And this is going to be my f of x. Okay, next one. 2 to the x minus 3. So hopefully you guys see the connection here, right? So same points. That point goes down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Right? And then these go like this, right there, right there, right there, right there. Connect the dots like we did in kindergarten. I'm trying. There we go. Whoosh. There we go. That's that one. So hopefully you guys see that, like I said, we've already learned this. We've already learned this before, right? So in particular, this is the other thing I wanted to point out, okay? That just like, hopefully you guys remember, vanilla had an asymptote right here, right? That was the asymptote for the blue one, for good old vanilla 2 to the x, right? Turns out when you move it up or down, that asymptote follows along. So this one has an asymptote here, right? And then the green one has an asymptote here as well. Okay, and the first one is +3, right? And the last one that we did, the green one, right? That asymptote drops 3. We are done. Woo! Okay. Next up. So I'm going to graph the parent function. I'm going to zoom out a little bit. There we go. I'm going to graph the parent function, okay? And then I'm going to graph these. That one and that one. So first off is going to be the parent function, okay? And that one, I'm going to put it up here. It's going to be right here, right here, right here. That one goes way up here. And then it's going to taper off. It's going to go right there. Some of you guys are probably thinking, how does he know these points off the top of his head? Don't worry. I'm going to show you guys the thing for it right now. Hopefully you guys see what the graph is going to look like. Right? We know that this is supposed to swoosh this other direction, right? There we go. Okay. Same thing. This one has its asymptote right here. All right. So now, let's do the first one. 1/2 x plus 3. 1/2 to the x plus 3, right? Hopefully this is ticking you guys off for something, right? X plus 3, since that is a +3, we know that it's going to be a side-to-side shift, right? But it works the same way. So if it's a +3, we move toward the negatives. So it moves all of our points over by 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then we'll just keep going that way. There we go. We provide the swoosh for this one. Swoosh. There we go. And I forgot the arrow on this one. There we go. Okay. We've got an idea of what this thing is doing, right? Okay. And then likewise, right? Let's go ahead and do the next one. hopefully you guys realize this one is saying minus 3. So if it's a minus and we're doing a horizontal shift, we need to move it toward the positive. It's always opposite of the sign, right? So it goes this way by 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then hopefully you guys see the rest. Bam, 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 bam. Okay. So here we go. Connect the dots like we did in kindergarten. Bam. So, like I said, we already learned this. We're just applying it to exponential functions in this case. Okay? All right. So here we go. Now we're doing the portion that I said I was going to defer to another chapter, right? This is it. We are now going to cover the horizontal reflection. Okay? So, first of all, let me graph them and I show you what each one of them looks like. Okay? And then I'll show you guys why they are what they are. Okay? So, for the first one, okay, let me go ahead and do the vertical reflection. So, if I wanted to do the vertical reflection, hopefully you guys remember, right? That's going to look like this. Minus 2 to the x. Whenever you have the minus sort of outside, right, all the way up in front, right, that told us that we were going to have to flip along the vertical axis, right? So basically, instead of going up like this, right, it's going to go down like this. It's going to whoosh downward, right? Now, to make it precise, I'm going to do the actual points, right? So I'm going to grab this point, this point, this point. And hopefully you guys see the points that I'm doing, right? And instead of going up, they're going down. The x value is going to remain the same. It's just going to go down instead. So this point is going to be, it's going to live like right there. This is going to live right there. It's easier said than done, really. Hopefully you guys see what I'm talking about. Bam. Halfway. 1. This one goes down to here. This one goes down to -4. Hopefully you guys see the shape. It goes, it's doing something like this right here. If anything, hopefully you guys find enjoyment in my grunting while graphing these things. Okay, there we go. Okay, so this one is the vertical reflection. Okay, nothing you haven't seen before. If you remember in chapter 1, if the negative was out front, we knew to flip it, right? Okay, the next one is going to be the horizontal reflection. Okay, so you guys see the shape of this. It's doing this time, right? Horizontal reflection means I get to flip it around this axis. It's going to go like that, right? As opposed to this one that sort of goes like that. Okay, so the height is perfectly fine, right? It mirrors on the other side. The x values are going to be the things that flip. So this point remains the same. Okay, this point moves over here. This point moves over here. Hopefully you guys see what's going on, right? And then now we get these other points. This one, this one, this one, this one. So this one goes over here. 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 And now we have our horizontal flip, or our horizontal reflection. It goes whoosh. Okay? All right, so now, how do we explain this one? This one is f of x is equal to 2 to the negative x. So notice now that that negative, right, is all together with the x, as opposed to this one where the negative is out front. Okay? Sound good? All right. So now, what I want to do is I'm going to show you guys something. Okay? So I'm going to write down the equation that I just wrote down, right? F of x is equal to 2 to the negative x. Okay, so hopefully you guys are thinking to yourself, yeah, sure. If you need to go review your exponential rules, the rules of exponents from section 4.1, stop and do that now. Okay, I'm going to go ahead and explain something, right, that hopefully is sort of ticking away in your mind right now. Okay, so here we go. We know that this right here, I just presented this to you, right? When you have 2 to the negative x, right, that constitutes a horizontal flip, right? Okay, this is the same thing as 2 times negative 1 times x. So I'm saying that negative 1 times x is going to be in the exponent, correct? All right. I can rewrite this line, this right here that I just wrote down. I can rewrite it like this. 2 to the negative 1 to the x. So here what I'm doing is I'm going backwards from the multiplicative distribution rule, or the exponent distribution rule, right? Where if I have a power to a power like this, I can just multiply them and put them in the exponent, right? And then lastly, this 2 to the negative 1, I can use in my negative powers rule, and I can rewrite it as 1/2 x. And I want you guys to look at this. This right here and this right here are exactly the same thing. Okay? Both of those things are exactly the same thing. Okay? Which, if we scroll way back up to the top, you remember those two functions that I made you guys play with? This one and this one? Those are horizontal reflections of themselves. That's it. That's it. Okay? Okay, so this is a nice kind of like neato way to find the reflections of stuff, horizontal or vertical. All right? Whew, rolling along here. Like I did before, each one of these things did something. And I kind of want to relate them back to what you learned in chapter 1, right? So there's now 5 things here, right? There's this one. Let me actually do a nice thick pink. There we go. Let me do that one. There's the A. There's the B. There's this new now plus or minus 1, an H, and a K. Okay? So this plus or minus up here is going to be your vertical flip. Okay? The next one, your A, is going to be the initial value, or your y-intercept. Okay? It just so happens, right, that when we look back at our A from chapter 1, right, this is the vertical stretch. Okay? The B, let me actually redraw that line. It's a bit too close. There we go. The B is what we consider our base, what we call our base. Okay, the plus or minus 1. This is brand new, right? The horizontal flip. Whoops, Z, horizontal flip. Okay, this minus H, right, is the horizontal shift. Opposite of sine. Whoops, opposite, OPP. OPP. OPP of sine. Sine. Oh boy. Maybe I should go back to kindergarten. I can't even write straight. Okay, and then the last K would be your vertical shift. So remember how I said we already learned all of this stuff. The only new one that I'm actually introducing here is this one, the horizontal flip. Okay, so all of this is great so long as you know what a graph of one of these looks like, right? And that is the thing that's right below. So thankfully, this graph is already inside that packet of graphs that I gave you from way long ago. This graph is already in there. This thing is already in there. Okay? Okay, so I want everybody to look at what the relationship is here. So your function is this. Y is equal to b to the x, right? Your b can be anything it wants so long as it's positive, right? And I want everybody to take a look at this, right? The first point is 0, comma 1. The next point is going to be 1, comma b to the first power, 2b to the second, 3b cubed, so on and so forth. So hopefully you guys notice this, right? That the x value matches the exponent because that's how functions work, right? But now you guys are thinking, okay, that should keep going maybe this way. Let me actually put a little bit more emphasis. Let me use the blue. It should have the same emphasis going that way, right? So that's what I'm going to show you guys now. So this point right here is also going to be 0, comma b to the 0. And if you guys remember from your exponent rules from section 4.1, anything to the 0 power is 1. Ta-da! Got it? The rest of these work the same way. So if it's -1, this is going to be b to the -1. The next one is going to be b to the -2. And this one's going to be b to the -3. Now, if you remember, again, your exponent rules, right? You know that we can change some of these. -3, comma, when you have a -3 as an exponent, that's the same thing as 1 over b cubed. -2, comma, whenever you have a -2, that's the same thing as 1 over b squared. Here, -1, comma, 1 over b. Okay, so the points follow along. Hopefully you guys see that, right? They're all different ways of writing the exact same thing. Different ways of writing the exact same thing. Got it? Okay. Last thing I got to cover is the dreaded domain and range. Hopefully you guys see that these two graphs, both of them, still keep going in either direction. They keep going that way and that way. So the domain is going to be -infinity to infinity. The rules still apply, right? We can't take the square root of a negative, right? If we do, we're talking about complex numbers, so we move on to that one. And then the other one is we can't divide by 0. In our y equal b to the x, we are not dividing by 0 at all, ever. We're not even dividing by anything. So neither one of the restrictions, right? Neither one of our restrictions sort of kicks out any numbers. So our domain is -infinity to infinity. We can plug in whatever we want. Okay? Next, our range. So our y values. Notice that all of these, right? And I'm going to draw it in, let's do a purple, a nice thick purple. There is still a horizontal asymptote right there. So our range is going to be 0, comma, infinity. So our exponential graph is going to get closer and closer to that asymptote that's at x equals 0. Sorry, y equals 0, right? But it'll never cross it. Boom. Turns out we learned nothing new today. Okay. What comes up next? Quick checks. Okay. Like I said, I'm going to get you guys to try these in class. If you'd like to try them on your own, you're more than welcome to. Okay. But you can try it. We'll do them in class. Yeah. And then after that is lecture questions. Bam. All done. So if you have any questions about the stuff that I just covered, ask me during class or during my office hours. Cool? Besides that, happy studying.